Boeing about to launch Starliner with helium leak. NASA and Rocket Lab preparing for tomorrow's back-to-back launches. Hey, I'm Lucas. Welcome to the SpaceX community. Let's get started. Hello everyone. Hope you all are doing good. Today, we will be discussing about the most heated topic in the space industry now. Yes, the Boeing Starliner capsule. NASA's Commercial Crew Program Manager, Steve Stich, has announced that Boeing's Starliner crew capsule is ready to launch on June 1st, despite a small helium leak in the propulsion system. After nearly 3 weeks of testing and analysis, NASA managers are confident that the leak does not pose a flight safety concern. The leak was detected in one of the Starliner's 4 propulsion modules, known as doghouses, and was traced to a flange where propellant lines come together. The investigation revealed that the seal in question likely was crimped or had a tiny defect, allowing helium to slip through. However, testing showed that even if the seal was removed from the flange, the Starliner could still fly safely. The helium manifold in question could be isolated, and the Starliner's many other thrusters could easily compensate. Mark Nappy, Boeing's Starliner program manager, stated that the launch scrub on May 6th had a silver lining as it brought the helium leak to everyone's attention, and they now know exactly where it was and have done all the work to understand the root cause, which will help improve the system in the future. The launch was delayed by nearly a month to allow for the analysis and to give the workforce time off over the Memorial Day holiday weekend. The Starliner's 2 NASA crew members, Commander Barry Butch Wilmore and co-pilot Sunita Williams, plan to fly back to the Kennedy Space Center next Tuesday to prepare for launch from the Cape Canaveral Space Force Station atop an Atlas V rocket at 12:25 p.m. on June 1st. If all goes well, they will dock at the International Space Station the next day and return to Earth on June 10th. The Starliner is equipped with 28 reaction control system (RCS) jets, and helium is used to pressurize the propellant lines, opening and closing valves in each doghouse as needed. Because traces of extremely toxic propellants could still be present in the plumbing, the seal could not be replaced or even inspected while the capsule was still attached to the Atlas V. The Starliner would first have to be hauled back to Boeing's processing hangar at the Kennedy Space Center for invasive repairs that would trigger a lengthy delay. Instead, NASA and Boeing ordered tests and analysis to fully understand the leak and what sort of problems it might cause in flight. The observed leak rate did not appear to be a concern, but engineers needed to gain confidence it would not dramatically worsen. They also wanted to make sure no other systems were affected. Stich said even if a suspect shirt button size rubber seal in the plumbing leading to one specific thruster failed completely in flight, resulting in a leak rate 100 times worse than what's been observed to date, the Starliner could still fly safely. "Should we be wrong about something, we could handle up to 4 more leaks," he said, "and we could handle this particular leak if that leak rate were to grow, even up to 100 times in this one, propulsion module." The investigation also revealed a design vulnerability, where, in the remote chance of major trouble with 2 adjacent doghouses, including the one with the helium leak, the Starliner could lose redundancy for the thruster firing needed to drop out of orbit for re-entry. The Starliner was designed to support 3 redundant deorbit capabilities. In one, the braking burn is carried out with 4 powerful orbital maneuvering and attitude control (OMAC) thrusters. The burn also can be carried out with just 2 working OMAC jets, or with 8 smaller RCS thrusters by firing them longer than planned. In the right circumstances, with adjacent doghouse modules out of action, the Starliner could lose the full 8-thruster RCS deorbit capability. We've worked with the vendor of the thruster, Boeing and our NASA team, to come up with a redundant method to do the orbit burn, to break it up into 2 burns about 10 minutes each, 80 minutes apart, to come up with a 4 RCS thruster deorbit burn, and to regain the capability of the original system, Stich said. This redundant method ensures that even in the unlikely event of a major problem, the Starliner can still safely re-enter Earth's atmosphere. The launch delay was necessary to allow for the thorough analysis and testing required to ensure the safety of the crew and the success of the mission. NASA and Boeing said that they are confident that the Starliner is ready to fly and that the helium leak does not pose a significant risk. Anyway, we will see if the mission will mark a major milestone in the development of the Starliner, which is designed to carry astronauts to and from the International Space Station. I'd like to quickly remind you to subscribe to our channel if you haven't already. We regularly upload informative SpaceX and space news videos that you won't want to miss. Be sure to turn on the notification bell so you're notified whenever we release new content. NASA is preparing to launch a pair of climate research missions within weeks of each other. The two spacecraft share the name Prefire, Polar Radiant Energy in the Far Infrared Experiment, and are designed to study how much heat is absorbed and emitted from Earth's polar regions, the space agency said. The first spacecraft, Prefire 1, is set to lift off on May 25th on board a Rocket Lab Electron rocket during a launch window that runs 7 to 8:15 p.m. A specific date and time for the second mission has yet to be announced. We're looking for new insights into how Earth's atmosphere and ice influence how much heat the polar regions lose into space, said Karen St. Germain, director of NASA's Earth Science Division, in a pre-launch teleconference. This is new information, and we've never had it before. We'll improve our ability to model what's happening in the poles, what's happening in climate, and ultimately, our ability to predict everything, from weather to climate. This is important to our strategy of providing Earth science that is actionable and can inform decisions for communities around the world on how to respond and adapt to changing environmental conditions. St. Germain also noted that by using a pair of CubeSats instead of larger spacecraft, NASA is exploring ways to create more targeted and agile missions in the future that may not require as much lead time or expense. Besides the cost and logistics benefit, Tristan Lecuyer, the Prefire principal investigator from the University of Wisconsin-Madison, said placing the twin craft in slightly different orbits will be critical in the science data they're looking to gather. Having one CubeSat, we'll be able to sort of map out what the emissions look like in the polar regions, but having a second CubeSat that flies over then, about 6 hours later, we'll be able to understand how changes, something like melting of the ice sheet or a cloud forming or an increase in the amount of moisture in the atmosphere, how that affects the emission between the two different CubeSats, Lecuyer said. So, we'll be using the two CubeSats to make measurements over the course of several hours apart, taking the difference between those measurements and trying to understand how the processes that are occurring in the Arctic are actually affecting the emission from the Arctic. Mary White, the Prefire project manager, said each spacecraft is roughly the size of a large shoebox and will be launched into asynchronous near-polar orbits. To measure the changes mentioned by Lecuyer, the spacecraft feature an instrument called a thermal infrared spectrometer, which has been flown in larger configurations by both aircraft and spacecraft. Although it's a developing technology, these thermopile detectors, we're flying more pixels on each detector than had been previously flown, White explained. We have an array of 8 pixels in the spatial direction by 64 pixels in the spectral direction. About an hour and a half after launch, Prefire 1 will open up its solar panels to start powering up its batteries. Those on the ground will try to establish communication with it via a ground station about 5 hours after launch. White said the spacecraft needs about 5 days for checkouts before controllers are ready to turn on its main instrument. At that point, they'll need another roughly 5 days to check out the instrument itself. However, White said they budgeted a month for this process, on the off chance that they need more time. Thanks for watching today's episode. Don't forget to subscribe and give us a thumbs up if you enjoyed it. Stay tuned for another great video tomorrow.